Here we're going to start factoring trinomial expressions with a leading coefficient of 1. For example, we have the trinomial x squared plus 6x plus 5. The leading coefficient is 1 and we have 3 terms. Remember, to factor is to write it as a product of factors. Factors being the terms or the items being multiplied to give us the answer. So x squared plus 6x plus 5 would actually be factored as x plus 1 times x plus 5. Now you might be wondering, well, how are we going to do that? Well, if you recall, when we looked at multiplying using an area model, we had a box similar to this. And when we would multiply, we'd have an x times an x to get x squared. So if you think about this, to get x squared, in order to get this x squared, I would have to multiply x times x. And we'd have 2 other boxes that had some sort of x term in them, and that's going to be because I'm going to have x times something, and I'm going to have x times something, so these are going to have x terms in them. And then I had a box that had a constant. In this case, the constant is going to be plus 14. Something that you can always count on. The x squared term can be placed in the top left corner, and the constant can be placed in the bottom right corner. Now, the key to this is we need to find what are factors of 14 that we can use that when we multiply with the x's to fill in these 2 corners, the upper right and the lower left, these 2 terms will combine to give us 9x. You might want to think of it as, what can I multiply to get 14 that will combine to give me 9? You might want to take the time to write out factors of 14. 14 can be 1 times 14, and it can be 2 times 7. Well, which of these would most likely get me 9? 2 plus 7 will get me 9, so if I do 2 times x, I have 2x. 7 times x will give me 7x. 2x plus 7x, if they're both positive, should give me a 9x. So I end up with factors of x plus 2 and x plus 7. Now, I can check by looking at what terms I have in my box. I have x squared. I have 2x plus 7x. 2x plus 7x does give me 9x. And positive 2 times positive 7 does multiply to give me positive 14. So I know everything in here is correct and the signs match on the outside. But I can always use the distributive property on my answer to check to see if I have factored it correctly as well. So x times x is x squared. X times 7 is 7x. 2 times x is 2x. And 2 times 7 is 14. We have the like terms in the middle. So we have x squared plus 9x plus 14. And if I go back and check, that is the trinomial that I wanted to factor. So my final answer is this x squared plus 2 times x plus 7. So let's practice this. I'm going to go ahead and continue making these squares. Those of you watching may even start seeing, oh, I can do this in my head, which is okay. So I had mentioned before, the squared term will go in the top left. The constant term will always go in the bottom right. And to get n squared, we would have to do n times n. To get this bottom right corner, we're going to have to look at factors of 35. Well, factors of 35 are 1 times 35 and 5 times 7. Well, which of these pairs will combine to give me 12? Well, 1 plus 35 is 36. Everything's positive, so I'm guessing everything here has to be positive, so that's not going to work. 5 plus 7 does add to give me 12, so I'm going to put 5 and I'm going to put 7 on my diagram. 5 times n is 5n. 7 times n is 7n. To get a positive 12n, these would both have to be positive, and a positive 5 times a positive 7, just to check. Positive 5 times positive 7 is, in fact, 35. So it is safe to say that n plus 5 times n plus 7 is the factored form of n squared plus 12n plus 35. Now the two we've done, everything has been positive. Let's take a look where our middle term is negative. We can still put the squared term in the top left corner, so x squared. The constant, the positive 24, in the bottom right. And we have x times x. Now let's think about this a minute. We know the constant term has to be a positive, but the middle term is a negative. Well, if the middle term is a negative, there's a couple of ways this can happen. One of them could be a negative and one could be a positive. But if that were the case, I'd be taking a positive times a negative, which would not give me a positive number. So both of these are going to have to be a negative because I'm going to have to take a negative number times a negative number to give me a positive 24. Factor pairs for 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6. Well, if they're both negative, negative 1 minus 24 is going to be negative 25. That's not going to work. They're both negative. We have negative 2 minus 12. That does give me negative 14. So let's write a negative 2 and a negative 12. So negative 2 times x would be negative 2x. Negative 12 times x is negative 12x. So we would get negative 14x with these two terms. And negative 2 times negative 12 is a positive 24. So this does factor as x minus 12 times x minus 2. Now, the order that I write my factors does not matter. You may have noticed that over here I wrote the factor expression that was on the top first, and this time I wrote the expression that was on the side first. It really doesn't matter because remember, multiplication is commutative, so 3 times 4 is the same thing as 4 times 3. Here we have the constant term is negative, while the middle term is positive. So if we think about the constant term is negative, keep in mind we're multiplying two numbers to give us a negative 30. That means that one of the numbers is going to have to be negative and the other number is going to have to be positive. And again, I'm going to list my factor pairs for 30. We have 1 times 30, 2 times 15, 3 times 10, 5 times 6. So 1 and 30, I don't think there's any way I can get that to give me a positive 13. 2 and 15, well, if I subtract 2 from 15, I can get a positive 13. But how many of you are saying, well, 3 and 10 give me 13? Yeah, 3 plus 10 does give me 13, but remember, we need one of them to be negative and one of them to be positive, since the 30 here is negative. If we use 3 and 10 and they're both positive, we won't get a negative 30. So we need to go with the 2 and the 15. Now keep in mind, we want a positive 13. So I believe we want a positive 15 and a minus 2 to make that happen. So negative 2 times y is negative 2y. Positive 15 times y is a positive 15y. So if we check, 15y subtract 2y does give us 13y. A positive 15 times a negative 2 will give us negative 30. So this factors as y plus 15 times y minus 2. And number 4. We have p squared and minus 21 as the values we know for sure. And we know p times p will multiply to give us p squared. Because our constant is negative, we know we will need a positive value and a negative value to multiply to give us a negative 21. If I look at my factor pairs for 21, that's 1 times 21 and 3 times 7. Hopefully you can see that 3 times 7 will get us 4, and we need a positive 4. So we want a positive 7 minus 3. So 7 times p is a positive 7p. Negative 3 times p is negative 3p. And we have negative 3p plus 7p does give us that positive 4p. Positive 7 times negative 3 does give us the negative 21. So our factors here are p minus 3 times p plus 7. Now, I encourage you to go ahead and use these area models for your factoring. But if you are quickly seeing, oh, I need to find what multiplies to give me the negative 21, that adds to give me the middle term, please make sure you're checking your answers, especially your signs, to make sure they work. This area model kind of forces you, or does force you, to check your answer to make sure it works. If you're trying to do it in your head, please make sure you're checking your answer.